Solving right triangles. So when you are solving a right triangle, that means you're finding all three sides and all three angles. So we're going to do the first two examples are just finding one piece, and then the next two are finding all the different pieces. So the first example, find the value of x. So what we have to do here, we talked about where is your little person standing. We're standing at the angle here. And we have to use our SOHCAHTOA to decide which trig function we're going to use. So based on this diagram, with the 68 being that reference angle, I have the hypotenuse here, and this would be the opposite. So I look up here and say which trig function uses opposite and hypotenuse. That's right here, that's sine. So this means we do sine of the angle always equals opposite over hypotenuse, so 28 over x. Okay, when you're solving these, you always have to multiply by what's in the denominator. So in this case, it is the x. So I get x times sine of 68 is 28, and then I would divide both sides by the sine of 68. So what you're typing into the calculator is 28 divided by the sine of 68, and that gives you approximately 30.2 for the value of x. Alright, example 2. So we are finding the angle here. So when we are finding an angle, we have to use the inverse. So I'm still going to start with the same process I did before. I'm going to label which is opposite, adjacent, hypotenuse, so on. So this one is going to be the opposite, and this one is the adjacent. So the trig function that uses opposite and adjacent, opposite adjacent is TOA, so that's tangent is what that means. So I'm going to say tangent of the angle, which is what we don't know, there's my variable, is equal to the opposite over the adjacent, so 9 over 10. So now to undo the tangent, we have to use the inverse tangent. So I say tangent, and the inverse is the little power of -1, we've looked at that before, of 9 over 10 equals x, and then that gets typed into the calculator. So make sure also when you're using any type of trig function that your calculator is in the right mode. It has to be in degree mode, or you're going to get wrong answers on here. So when you type this in, it should give you approximately 42 degrees. Alright, so we're going to have to use a combo of both of these for the next two examples to solve the triangle. So that means we're finding all the sides and all the angles on here. So I have angle A, angle B, angle C. I have side A, side B, and side C. So angle, we have a few of these that are given to us already. So like angle A, we already have, that's 40. We have angle C, that's 90. Okay, and the side that is opposite of the angle, so like side C is opposite of angle C, like this. So this is where the 3 is. This would be side A, and this would be side B. So what I'm going to find next is I'm going to find that angle B, and that comes from the triangle sum theorem, which you would have learned in geometry, that says all three angles in a triangle always have to add up to 180 degrees. So if I take 180 and I subtract the 90 and subtract the 40, that leaves me with 50 degrees for right here for angle B. Okay, now I need to actually set up some trig to find one of these other sides. So if I'm going to work on finding, let's say I'm going to find side A here, I would have the opposite and the hypotenuse on that triangle. So I'm going to say sine of 40 equals a over 3. Now I'd multiply both sides by 3. And that gives you an A value of about 1.9. Okay, so now that I know what A is, this is 1.9 here. Now to find B, all I have to do is the Pythagorean theorem. I have 2 out of the 3 sides of a right triangle here. So I would say 1.9 squared plus B squared equals 3 squared. Okay, so if you go through, do the Pythagorean theorem, I'm not going to go through every step of that. You would get 2.3 for B. So A was 1.9 and B was 2.3. Okay, next page, last one to do together here. Alright, so same thing, I'm finding all 3 sides, all 3 angles here. So we're going to have angle A, angle B, side A, side B, and side C. Alright, so I'm going to start by finding side A, which is the one that's, actually, sorry, back up. I'm going to label the stuff that I already have. So I know that angle C is 90. I know that side C is 9, and I know that side B is 6. So now I'm going to go and I'm going to find that missing side A there. So the 9 is the hypotenuse, so that has to be the C in the Pythagorean theorem. 6 squared plus A squared. I guess I should do this the right way, shouldn't I? Technically it doesn't matter, but we'll try to be more accurate here. So I'm finding A. So A squared plus 6 squared equals 9 squared. Okay, so that's going to give you 36 and 81 for these. Subtract 36 from both sides, and you get 45. So the square root of 45 is about 6.7. So that's going to go here. Okay, now we need to find one of the angles. So I'm going to start with finding angle A here. So that's where my little person is standing. So I look at the diagram and say, which pieces do I have? Do I have adjacent, opposite, hypotenuse based on angle A? This would be the hypotenuse, and this would be the adjacent. So the one that uses adjacent hypotenuse is cosine. So I'm going to say cosine of angle A equals 6 over 9. And then whenever you're trying to find an angle, you have to use the inverse. So I'm going to say cosine with the little negative 1 power. That means inverse. That's what A is going to be equal. So if I type that into the calculator to the nearest degree, that gives me an A value of about 48 degrees. And then if I want to find the other angle, I take 180 minus 90 minus 48, and that leaves me with 42 for angle B.